Good morning, teacher. My name is Joseph Martin de Odor Carvajal, and I talk about the WorkShop 4. In this case, we simulate a truck with a tractor. So, in step 1, we need to open the software, Adam Cars, and the guide provided in Google Drive. Activate the Manager Play system. In the Tools, apply in Manager and activate or check in Adam Car Truck. Then OK. Step 2, create a full vehicle assembly. 5, open assembly. Then anti-click or right click in the text box. Then search attract shard assemblies. Then found tractor semi-trailer.ac. Then put open. And step 3, verify the system units. In this case, we work with MMKS. Then put OK. Step 4, simulate full vehicle system. On initial velocity, put 60 for the first test. And the second test, we need to put 80 for initial velocity. Then animating analysis result, we have the track. We need to put play and the simulate start. Then plotting analysis result. In this case, we have the test 1 or the first test and the second test. We compare the accelerations of trailer and tractor on the component lateral. In this case, we have the analysis of the plot. In this plot, we can see the behaviors of the acceleration of trailer and tractor, in both cases on the component lateral. So in the plot on the left, the initial velocity is 60 km per hour, and for the right plot, the velocity is 80 km per hour. In both cases, we can see the curve of the trailer accelerations. It's less than the curve of the tractor acceleration, and in the second plot, the curve has a different behavior due a greater effort to return to the equilibrium point. We can see this is the result of rearward amplification. For the first plot, we can has a value of 0.89 and 1.06 for the other plot. So in comparison with the table of the guide, the second test provides a limit for this type of vehicle. In this case, we have the graphic, the type of the truck, 5-axle tractor semi-trailer with 45 feet trailer. We have the rearward amplification, have a value of 1. Then the workshop questions. Is there any relation between rollover and steering system in the heavy truck behavior? Vehicle rollover resistance can be enhanced using differential braking control, rear wheel steering, front steering control, suspension damping control, or the combination of any of them. In each control, the controller receives the vehicle dynamics information from various sensors, such as a lateral accelerometer, a roll velocity sensor, if available, and suspension displacement sensors, and determines a control action to be taken. A balance between controlling vehicle roll motion to achieve the optimal vehicle response. Therefore, detection of the current and impending vehicle situations, especially pertaining to the vehicle roll, is vital for the quality of control. What kind of consequence produce higher velocities in lane change maneuvers? In this case, we can see the result of the simulations. In the second simulations, the initial velocity was 80 km per hour. So in the plot, we can see an irregular curve in both curves. In this graphic, curves make an effort to return to the lane change. This variation of the velocity produces the rollover of the truck and accidents. In this case, we can see the it's a normal variation of the curves. In this case, in comparison with graphic 1, it's more normal, but in graphic number 2, in the plot number 2, we have more effort for this component to return the equilibrium point or or to the lane change. How does influence size and weight variables of the stability and control properties of heavy truck? In this case, we answer that the roll stability of heavy daddy trucks and truck combination is excused both of the level of the fundamental mechanics of vehicle response, and from the viewpoint of the quantitative influence of size and weight variables. The presentation or fundamental begins with a case of a rigidly suspended vehicles and wheels and builds up to the case of a tractor semi-trailer. In this case, size and weight consideration cover variation in axle load, gross weight, and overall, with as well as incidental issues involving the height as possible lateral offset of the payload center of gravity. Size and weight influence on roll stability are interpreted in terms of the likely implication. For rollover accident involvement, we can see this in this graphic. This graphic, I get this graphic for the guide. Number 4, for plotting results, estimate rearward amplification for both cases, compare and display values obtained. And this is the way how we need to calculate the rearward for both simulations. For a first simulation, we have the value of peak lateral acceleration trailer. We have a value of 0.111 or 111. From the peak lateral acceleration tractor, we have the value of 0.1246. The final result is 0.89. For the second simulation, we have the rearward amplification. We have a value of peak lateral acceleration trailer 0.1716, and for the peak lateral acceleration tractor, we have a value of 0.161, and the final result is 1.06. On the left, the initial velocity is 60 km per hour, and for the right, the velocity is 80 km per hour. And in the second, it has a different behavior to do a greater effort to return the equilibrium point. We can see this in the result of the rearward amplification. For the first, we can have a value of 0.89 and 1.06 for the second. So in comparison with the table of the guide, the second test superates the limit for this type of vehicle, so it's more dangerous and difficult to return to the normal behavior. This is all for my PowerPoint. Thanks.